In today's session, we learn about the other topic, which is read-only memory in Unit 5. So in last class, we learned about how the memory is decoded and how to obtain the address decoding, coincident decoding, address multiplexing. These are all the concepts we covered in last session. So let me learn about what does mean by a read-only memory. So in which application we are going to use this, and as well as the types of your read-only memories. Now, so let me learn the block diagram of your read-only memory. As since it is a permanent storage device, so once you establish the pattern or you program your ROM, so it will be fixed one. So there was no chance to change that outputs of your ROM. So hence it doesn't have any data inputs. So in order to enabling your or transferring your new data into the ROM. So this is only used for reading purpose. So you don't have your control input of read or write. So hence it is having only the key inputs of address inputs which are used to locate your particular memory word, and from that memory word whatever the data is loaded, that will be retrieved only. And this also comes under your non-volatile memory. So even the power is turned off or on again, so the content in your memory will not be changed. So now, this programming your read-only memory is not in the hand of your users or not in the hand of your programmers. So it is designed by the designers. So they will give you some a specific pattern to to make over that read-only memory. The patterns they will give. So once they give, so they will send that tables. So after filling the tables, the designer can fill that table according to their requirement. So now in the industries, so they were going to design based on that, and they will mask that program, and then they will provide that required pattern. So initially all the connections which are connected on your ROM will have your intact connection. Upon choosing that our designer specifications, they will program your each memory. But once they program, so it will not be reprogrammed. So or if your power is on or off, so the data may not be lost. So it is only used for the reading purpose. So the hence it doesn't have your control input. So if you have k number of address inputs, then you can have your total memory words from this ROM is 2 power k number of memory words you can obtain. And based on your n number of data bits, for example, now if it is having 1024 bytes, so each memory word can store 8-bit data, and in order to locate your 1024 memory words, we require total number of address inputs are 10. So now let I take a simple example with this 32 by 8 ROM. So here that 32 indicates your number of memory words in your ROM, and this 8 indicates, the digit 8 indicates your number of data bits which is stored in each memory word. So in order to locate your one of the memory word, so this 32 it can be written in terms of your 2 power is 2 power 5 become your 32. So hence it required total number of address lines are equal to 5. So total number of address lines is equal to 5. So we can write here 2 power 5 is equal to 32. 2 power 5 is equal to 32, and now that 2 power 5 5 number of address lines are required. So hence here these 5 number of address lines are denoted as your I0 to I4. So the first address input is denoted with I0, and the last address input which will be denoted with your I4. So total number of address lines required is 5. So the order of the decoder must be equal to 5 into 2 power 5, or you can write it as 5 into 32 decoder. So based on your address inputs, so one of the memory word is selected, and based on your selected memory word, the data which is loaded on this, so will be retrieved from this multiple input OR gates. So now here I have total number of OR gates are 8 number of OR gates which are having the total interconnections. So each OR gate is having total number of inputs which are 32. So 32 number of inputs are available on your each input of your OR gate. So 32 inputs are available on your each OR gate. So you have your total number of OR gates are 8. So total interconnections on your OR gate is 32 into 8. So 32 into 8 is, so 256 number of internal connections are available on your output terminal. So here from that output terminal interconnection, so based on your programming, so you can retrieve the logical data of 1 or logical data of 0. So once if it is programmed, so the logical 1 is denoted with this cross mark. So if there is no symbol on your intersection point, so which denotes a logical 0 is stored. So for example, now I have given this truth table of your prompt. So programmer only once it is programmed, after that it cannot be reprogrammed. So now here I have taken I0, I1, I2, I3, I4 are my address inputs, which can select the one of the memory words. So total memory words, so which will be 32 memory words, so which are obtained from your fixed AND gates, and that fixed each AND gate will give you the one of the midterm. So M0, M1, M2, M3 till M31. So total 32 midterms are there. I have given in that few midterms. So just observe here. So first memory word is selected by transferring all input address inputs with 000. So if I transfer I0 to I4 000, so the output which are obtained from this data output bits are, so A0 must be 0, A1 must be 1, A2 is 1, A3 is 0, A4 is 1, A5 is 1, A6 0, A7 is 1. So now just to see here, so wherever the 1 I wanted to store, so there was a intact connection. So the 0 is a blown fuse, so there is no connection between on your intersection of your this horizontal line, which is a memory word, and your vertical line, which will give you the data input to the OR gate. So hence here A7 is 1, so we have given here a cross mark, where A6 is 0, hence no symbol is there. A5 is 1, so A4 is 1, so A3 is 0, A2 is 1, A1 is 1, and A0 is 0. The same manner, let me select the third memory word. So in order to select the third memory word, so which is 3, so I need to transfer on your address inputs, which are I4 must be equal to 0, I3 is 0, I2 is 0, I1 and I0 must be 1, 1. So upon transferring this address bits of 0, 0, 0, 1, 1, so that third memory word is selected. When this third memory word is selected, so the output which are obtained from this multiple input OR gate is, so here A7 is having a cross symbol, so which is loading with a logical 1. A6 doesn't have that interconnection on your intersection point, no symbol is there, hence it loads here 0. A5 is 1, A4 is 1, A3 is 0, A2 is 0, and A1 is 1, A0 is 0. So this is the programming table. So based on this programming table, so initially all you have your intact connections between this each intersection point of your row and column, but upon programming you have to blow that switch. So like using your electronic devices, for example a diode is connected from this word of your memory word of your 28th to the line of your A6. So like this, so you have so total 256 patterns are available, because you have here so 32 number of memory words and 8 number of OR gates. So each OR gate is having 32 inputs. So 32 into 8, so which is equal to 256 patterns are there. So blown fuse indicates the logical 0, and your on fuse, intact fuse can indicate that a logical 1. So now hence here we can obtain the output by loading your logical 0 or logical 1 onto your, by diffusing your fuses. So we can obtain your logical 0 on your each word. So you can store your logical 0. So actually programmers cannot store, so only the designers, and in the industry they can do this diffusing your fuses, and they can give you different patterns, so which can give you the programming. So once you program that, so it will be fixed, so your power is switched off, so your data which is obtained from your ROM may not be changed. So in the same manner, here we can also use these ROM prompts or ROMs, so using your combinational circuits, since so your each memory word is generated from the AND gate, so which will give you one of them in term, hence we can implement your Boolean functions using your ROM. So now let me design a 4-bit binary code into a 4-bit gray code. So this is your basic binary input, which is your binary input, so which is started with 4-bit binary with 0000 to 1111. 15 different combinations we have it on your input. For this 15 different combinations of input, so the equivalent of gray code we wrote it. The 00 is 00, 001 is 001. For 2 it will be equal to 0010. So exclusive OR operation we performed here. So now, so in order to obtain your G3, it will be copied with your B3. So hence we copied your B3 is exactly equal to G3. To obtain your G2, we need to perform an operation of exclusive OR between your B3 and B2. So now see here, B3 exclusive OR of B2 is 0. So 0 exclusive OR of is 0. So 0 exclusive OR of 1 will give you the G1, which is 1. So 1 exclusive OR of 1 will give you the output, which is equal to 0. So like this, so you have to find out your gray code outputs for the given binary numbers, as we already learned how to convert your binary input into your gray code. So by performing your exclusive OR option between the binary bits, you can obtain your the gray code bits. Always your most significant bit is as it is that of your gray code, and the next bits of your gray code is obtained by doing the exclusive OR operation between B3 B2, you obtain G2, B2 B1 you obtain G1, B1 B0 you obtain your G0. So like this, so all the 16 combinations we obtained your gray code outputs. Now how we will do your programming using your ROM. So now as here 0, so your inputs must be connected, the address input must be connected to the binary inputs. So B0, B1, B2, B3. So in order to select one of the memory word, so we have connected 4 number of inputs which are binary by address inputs, which are connected with your binary inputs. And since it is 4, so you have obtained your 16 outputs. So for 4 by 16 decoder we are going to use here. So which will give you the 16 minterms or 16 memory words, and then upon this, so we are going to connect your OR gates. So these AND gates are fixed one, where OR gates are programmable. So hence here, so if M0 is there, so no, M0 is having G3 is 0, G0, G2 is 1, sorry, G2 is 0, G1 0 and G0 is 0. So hence no cross mark is there on your intersection. M1 equivalent code of your gray code is, so 001 equivalent code is 001. So hence G0 is 1. So where your 0010 equivalent code is 0011. Hence here we have, wherever the 1 is there on your output terminals, we cross that on your vertical line of your OR gate, or your OR gate inputs are programmed. So this cross mark indicates logical one. So this is the equivalent gray code. So here 001 is your 0001. So hence only on the last bit we have given your cross mark. The equivalent code for M2 is 0011 on your gray code. Hence, so G1, G0 are 11. So equivalent code for your M3 is 0010. Hence we given that G1 is with a cross mark, G0, G3, G2 are with the zeros. Next, so 00 for binary input of 40100, it will be, so 0110 is the equivalent code. Hence we have given your 0 is on your G3 is without any symbol, a cross symbol is absent here, so which denotes a logical 0, whereas here we present a cross symbol which denotes the logical 1 is present on this line, so which is connected to the G2 input. And now, so here M4 is 1, so which is on G1, and G0 is 0. So like this, so we have to cross your vertical line intersection points, so wherever the 1 is loaded. So if the 0 is loaded, then there is no symbol is indicated on your programmable inputs of your OR gates, which can implement or which can convert your given binary into your equivalent gray code. In the same manner, you can also implement the same functionality, your different functions of booleans using your prompt. So now your function f1 of ABC is equal to sigma m of 037, f2 of ABC is equal to sigma m of 157. So now we wrote that a truth table, so only it is having the minterm 037, so we provided that minterm functional values are 1 for 0 minterm, 3 as well as 7. F2 is 157, so hence for minterm 1 it is given within your truth table 1. So 101, so 5, minterm 5 is functional value is 1, so we give your F2 functional value is 1. Remaining all will be zeros. So now, so here a prompt, so your address inputs are transferred with your input functional variables A, B, C. Outputs which are obtained only two outputs, so hence we are going to take two OR gates. So now here two OR gates, so two OR gates we have taken, where here 037 is connected on your function 1 to implement. So hence we have provided your programmable connection or logical one state on this, so with a cross mark, so M0, M3, M7, whereas F2 is sum of your two, sorry, sum of your M1, sum of your minterm of M1, M5, M7. So hence we have given this, so with a programmable connection, that this OR gate, second OR gate, is having the inputs from the minterm M1, so it is also having the, like, so you can give you with multiple inputs, but so for a programmable connection we have replaced that with a single input line. So like this we have given as a single input line, and three perpendicular lines which are from your M1, one is from M1, the other is from M5, and the last one is from M7. So like this it can implement your function F2 value, and the first OR gate will implement your function F1 if you connect your M0, M3 as well as your M7 value. Now programmable read-only memory can consist your fixed AND array and programmable OR array. So like this we can also implement your combinational circuits using your prompts. So and we have your types of memories, types of ROM devices. So three, basically they are classified into three categories. So those are called as PROM, EPROM and erasable program EPROM, and again that EPROM is classified into EPROM and EEPROM as well as your EEPROM. So it's a your PROM is a programmable read-only memory. So now once only one time you can program that. So upon programming that, so your data is permanently stored in that data, so which is known as your PROM. So a PROM is the erasable programmable read-only memory. In this erasable programmable read-only memory, so you have to expose your chips or the EPROM devices almost with a 20 minutes. So then the complete program whatever you have previously loaded, that will be erased. But this process of erasing will take more time. Along with that, so you have to remove your chip from its processor, and then you have to expose that on your UV light. So you have to use a window, and through that window only we have to transfer your UV light. So the entire, and here the process of deleting your information will be, entire data will be erased completely. So not your selected portion by the user. So hence, so this is the only disadvantage. But here, so these are available with which are cost effective as well as they are very reliable. So we can prefer your EPROM devices. So if you are preferring for erasing of your or reprogramming your read-only memory devices. So next, let me move to your another classification which is EEPROM. So electrical erasable programmable read-only memory. Here the method of erasing is by passing your electricity to through that special pin is available. So through that special pin you are going to transfer the voltage. So when that voltage is transferred, so then on a particular selected memory location, so the data must be removed or your erased. So it will be erased completely. So now, so here by it will do the bit by bit erasing or byte by byte erasing. But whereas EEPROM, it is it is the method of erasing completely. The EEPROM memory values are stored, previous contents are erased completely. But here we can selective portion of your memory can be erased by selecting your memory location and by passing your electrical signals through a special pin. So then it will take a few milliseconds to erase completely. So and that erasing technique so is limited for a number of times. So generally it will be 10,000 times you can erase and reprogram that. Thank you.